Hello students, we are lecturers from KDU College. We have prepared for you videos on Mathematics Past Year Paper 2018, Paper 1 and Paper 2 solutions. Let me introduce myself. My name is Malini and I've been teaching for the past 20 years.
Hello everyone, my name is Morgana. I'm an A-level lecturer. I have been teaching since 2012.
Hello everyone, my name is Raymond. I'm a business faculty lecturer. I've been teaching for the past 15 years.
Hi students, I'm Chang. I'm an A-level lecturer. I've been teaching for about 9 years. So hope you will learn from the videos that we post, and good luck for your upcoming SPM.
Question 1a. It is given that set K equals to perfect square numbers and set L comprises 9, 16 and 25. So the question requires you to complete the Venn diagram in the answer space to show the relationship between set K and set L. Set K says perfect square numbers. So perfect square numbers would be numbers such as 1, 4, 16, 9, 16, 25, 36, 49, 64 and so on. So L is given as 9, 16 and 25. So these are the three numbers that is in K as well as in L. So how do we draw the Venn diagram? So you need to complete the Venn diagram for 1 mark. So we can draw the Venn diagram as 9, 16 and 25 and label it as L. So that is question 1a for 1 mark. Moving on, let's look at question B. Question B for 2 marks says the Venn diagram in diagram 1 shows the sets X, Y and Z. The universal set is X union Y union Z. Question wants you to state the relationship represented by the shaded region between sets X, Y and Z. So as you can see, Z is fully shaded, X and Y is partially shaded, connecting both X and Y. Therefore, how do we write the relationship? So that would be when partial X and Y is partially shaded, that means that will be a joint. Fully shaded means all the elements in Z will be included, meaning it is a union. Therefore, the answer would be X joint Y, and all these will be the union of Z. So the answer for 1B would be X join Y union Z for 2 marks. Question 2. Diagram 2 shows a cuboid P, Q, R, S, T, U, V, W on a horizontal plane. Point N is the midpoint of QR. If PS, QT is 6 centimeter, therefore QN would be 3 centimeters and NR would be 3 centimeters. The height would be 4 centimeters and the width is 5 centimeters. Question A. Name the angle between the plane TWN, the triangle TWN, and the plane PQRS, the rectangle PQRS. So this is TWN and PQRS. So this clearly says the angle would be this angle that connects the rectangle as well as the triangle. Therefore, the answer for question A would be angle WP and R. W and R. Question B. Calculate the angle between the plane TWN and PQRS, meaning they would want to know what is this angle. So this is a 90 degrees triangle, right angle triangle. Therefore, we need to find what is the angle for W and R. So this is using the formula tangent theta. Why tangent? Because we have opposite over adjacent. So the formula for tangent is opposite over adjacent. So tangent theta would be opposite is 4 over adjacent 3. So then using your calculator, inverse tangent 4 over 3, which would give you the answers. Using your calculator, shift tangent 4 over 3 would give you, so this is the answer, 51.13 degrees. 51.13 degrees for 3 marks. Whole question of 2. Question 3. Now before we start looking at question 3, I would like to request students to ignore the information given here, the x centimeters. Please ignore this information. So let's look at question 3. Diagram 3 shows a garden path with a rectangular shape. There are 8 similar circular stepping stones built in the path. Given that the area of the path is 32 meters square, find the diameter in meters of one piece of stepping stone. Meaning that the 8 stepping stone is equivalent to x plus 4. And they have given the area as 32 meter square. Okay, let's look at the solution. So if this is given as x plus 4, that means we can assume the height of the path would be x plus 4 divided by 8, which is equivalent to the diameter of a circular stone. Okay, now let's start by looking at how can we find the solution for this. So given the area is 32 meter square, which is x plus 4, the length, multiply with the width, which is x plus 4 over 8, must give you 32. So this is an algebraic equation where you can find the solution by multiplying the algebraic equation. So we can say that x plus 4 square, bring the 8 across, that will give you 8 times 32 would be 256. So x plus 4 square root 256 would give you 16. So that means x is 12 meters. So what would the diameter be? So diameter is x plus 4 over 8, meaning that it is 12 plus 4 divided by 8 would give you 2 meters. So when you get 2 meters, you will get 4 marks for this question. Question 4. Diagram 4 shows a composite solid formed by joining a quarter cylinder and a cuboid which lies on the horizontal plane. Question requires you, Okay, more information are given. It is given that the height of the cuboid is 9 centimeter, meaning that the height is 9 centimeters, the height of the cuboid. And the volume of the whole diagram here given as 1206/7 centimeter cube. Question requires you, using pi as 22/7, calculate the height in centimeters of the quarter cylinder, meaning that they want you, this is the radius of the circle, 12 centimeters. This would be the height of the cylinder. So looking at the diagram of the cuboid, we know this is the height, this is the length 6, and this is as well as 6 centimeters. So 6 is the length, the width, and 9 centimeter is the height of a cuboid. For the cylinder, okay, so total volume is 1002/6 centimeter cube. So let's look at the formula on how to find the volume. So we know volume is volume of cuboid plus the volume of the cylinder. So we know volume of the cuboid is length times width times the height, and what is the volume for cylinder is pi r squared h. This is a whole cylinder, and for your question it is given as a quarter cylinder, therefore we have to divide by 4. So length is 9 centimeters, width 6, height 6, plus, and the volume given as 1002/6/7 total volume. And what is the volume of the cylinder? Pi is given as 22/7, radius is 12 centimeters time to the square, 12 squared times height is unknown. So then you need to solve this. So 1002/6/7 equivalent to 9 times 6 times 6 would give you 324, plus this is 144 times 22/7, which would give you 792/7 h. So we need to solve h. So 792 h/7 equivalent to 1002/6/7 minus 324. So we bring it this side, so this minus 324. So this will give you h equivalent to, this is 792 h. If you solve this, you would get 4752/7. Therefore h would be 4752 divided by 792 would give you as 6 centimeter.
Hi students, welcome back. Today we will learn how to solve question 5. Diagram 5 shows a rectangular fish pond with a perimeter of 62 meter. It is given that the length of the fish pond is 3 times its width. Okay, this is a standard algebra problem. There are two unknowns: the width of the pond x and the length of pond y. As the perimeter of rectangular pond is 62 meter, we can write down it as x for the both side of the width, so plus width the length is y plus 4 meter. So when it's come to two sides, 2 y plus 4 equal to 62 meter. So we can solve this. Okay. Now we can simplify this equation by dividing with 2. If you divide by 2, you will get x plus y equal to 27. So this is the first equation. Next, the length of the fish pond is 3 times its width. So we can write down this as y plus 4 equal to 3x. So y equal 3x minus 4. So this is the second equation. Okay, now we can substitute equation 2 into the equation 1. X plus 3x minus 4 equal to 27. Okay, we can solve for x minus 4 equal to 27. 4x equal to 31. So x equal to 31 over 4 meter. So from here we can find the width, that is 31 over 4 meter. Let's be back to the question. The question is asking the length, asked us to calculate the length in a meter. Since the length of the fish pond is 3 times with its width, so we directly can calculate this. So 3x. So x is 31 over 4 meter. So 3 times 31 over 4. So the answer for the y, or for the length, we will get is 23 1 over 4 meter. So this is the answer for the length of this pond. Question 6a. State whether the following statement is true or false. The significant figure of 123.4500 is 7. Okay. So from here we can see that there's a decimal point. Okay. So normally we know after the decimal point, if there is 0 exists, we still take it as a significant figure. So 1, 2, 3, 4, 5, 6, 7. So this statement is true. So we can write the answer here. It's a true statement. B. Write down the converse of the following implication. If an angle lies between 0 degree and 90 degree, then the angle is an acute angle. Okay. One of the easiest question that student can score. Just inverse the statement where bring behind statement to in front. So the answer is if the angle is an acute angle, the angle lies between 0 degree to 90 degree. 6c. Write down the premise to complete the following argument. Premise 1 is, if x is an odd number, then x is not divisible by 2. Okay, now they say that x is not divisible by 2. Okay, let's we go to the conclusion. 24 is not an odd number. Okay. Since 24 is not the odd number, it is divisible by 2. So the answer for premise 2 is 24 is divisible by 2. Based on the information below, make a conclusion by deduction for the surface area of sphere with radius 9 cm. The surface area of a sphere with radius r centimeter is 4 pi r square. Okay. The radius of the sphere is 9 cm. So we can substitute the value into the formula given. So the area is 4 pi r radius square. So we can just substitute here. Okay. Since the question asking us to deduce the conclusion, we can write down as a the surface area of a sphere with radius 9 cm is 324 cm square. Question 7. Diagram 6 shows two parallel straight lines PQ and ST drawn on a Cartesian plane. Okay. The straight line QT is parallel to the x-axis. So, the first question is the equation of the straight line QT. So, we need to find the equation. QT is a parallel to x-axis. So, QT is passing by y. So, y is 3. From here we can find y is 3. So, for the Q, we can write down here x 3. X, we can't find the x, the y is 3. So, the equation is y equal to 3. Okay. Question B, the equation of the straight line ST. So now we are going to find the equation for the ST. PQ is a parallel to ST. It means that gradient of the PQ is the same with gradient of ST. So the gradient of PQ is 2y equal 4x plus 3. Is a straight line equation of the PQ. Now we can solve this. Okay, so the gradient is 2. It's 2. Okay, now we can substitute the coordinate of the T. So the formula for the gradient So if you substitute, x minus 5. We can solve now. Okay, so we times 2 times x, 2x, 2 times 5, negative 10. Okay, and we are write back this here, y minus 3. So y equal to 2x minus 7. So this is the equation for ST. 7c, the value of k. So now we need to find the value of k. The coordinate of S is k, 0. So y is 0. Okay, so we can write this as y is 0, and we can substitute the value in a straight line equation of ST. So y, we get 2x minus 7. So as you know, y is 0, so 0 equal to x minus 7. 7 to okay, negative 7. When you bring it to your left side, it becomes 7. Okay, positive 7. So x 7 divided by 2. So the value of the k is 7 over 2. Question 8. Given P in a bracket 4, negative 2, 3, negative 1, Q equal M in a bracket negative 1 and negative 3, 4 and I, identity matrix, equal to 1, 0, 0, 1. Okay, the questions A is asking us to find the value of M and of N if PQ equal to identity matrix. Okay. As we know that 1, 0, 0, 1 is an identity matrix, means when multiply any matrix we get 1, 0, 0, 1, that is one matrix is inverse of another. Okay. Now we need to find for the M and N. So that is for the Q. So Q equal P inverse, since Q is inverse matrix of P. Negative 1, 2, negative 3, 4. Okay, now we can use the formula 1 over AD BC D negative B negative C A. Okay. So from here we can see 1 A D. So A is negative 1 times with 4. So we will get negative 4 minus BC. 2 times with negative 3, we will get negative 6. So negative 6. Then we can apply D is D. We can apply this fact because we already inversed the Q. So negative 1, 2, negative 3, 4. Okay. Okay, so 1 over negative 4 minus negative 6, so we will get 2. Okay. Then negative 1, 2, negative 3, 4. Okay. So we already know what is the answer for M, right? Okay. Now for the N, we write it back, and negative 1, negative 3 and 4. Right? So from here we can see that what is the answer for N. Okay. So the answer for 8A is M is 1 over 2, N is 2. So we can write this here. Eight B. Write the following simultaneous linear equation as matrix equation. 4x minus 2y equal 3, 3x minus y equal 2. And by using matrix method, calculate the value of x and of y. Okay, so let me write it back. The equation here, 4x minus 2y equal 3, 3x minus y equal 2. Okay, what we can do is write down the equation into the matrix form. Okay, 4, negative 2, 3, negative 1, xy equal to 3, 2. This is the exactly same with the previous matrix of P. Okay, what I'm going to do first is I'm going to move the matrix to other side. So I will inverse it. Okay, now we can solve this. Xy negative 4 plus 6. We need to apply the equations, the previous equation that I used for the 8A. Then you need to inverse this. So negative 1, 2, negative 3, 4, 3, 2. Okay, so we can solve this. 1 over 2. This one, negative 1 times 3, 2 times 2. Negative 3 times 3, 4 times 2. So we can write this as negative 1 times 3. We will get negative 3 plus 2 times 2, 4. Okay. Negative 3 times 3, negative 9 plus 4 times 2, 8. So 1 over 2. Negative 3 plus 4, we will get 1. Negative 9 plus 8, we will get negative 1. Okay, so this is a xy. Okay, so from here you can see that xy 1 over 2 divided by 1, we will get 1 over 2. 1 over 2 divided by negative 1, we will get negative 1 over 2. Right? Okay, so now x is 1 over 2, y is negative 1 over 2. So this is the answer for 8B.
Question 9. Diagram 7 shows a distance time graph for a journey of a car from Kuala Lumpur to Ipoh. So this is the distance time graph. This is the time in 24-hour system. The journey started at 12 and it ended at 3:20. Distance from Kuala Lumpur to Tapa, distance in kilometers, 152 kilometers, and Kuala Lumpur to Ipoh would be 205 kilometers. Let's look at the question now. Question A. State the duration of time in minutes the driver stopped and rest at Tapa. So if we look at the graph, from Kuala Lumpur, the driver reached Tapa at 3:45 and he rested till 2 o'clock. So 1:45 to 2 o'clock would be the time that he stopped and rested at Tapa. So state the duration of time in minutes would be 2 o'clock minus 1:45. That would give you 15 minutes. Question A. Moving on, let's look at question B. Calculate the speed in kilometers per hour of the car from Kuala Lumpur to Tapa. That means from Kuala Lumpur to Tapa. Calculate the speed. So according to the formula, speed would mean distance divided by time. So the speed from Kuala Lumpur to Tapa would be 152 kilometers divided by 1 hour 45 minutes, because the driver left at 12 and reached Tapa at 1:45. So the time would be 1 hour 45 minutes. So 1 hour 45 minutes. 45 minutes, it's equivalent to 45 over 60, which means this is 0.75 hours. Therefore, speed would be 152 kilometers divided by 1.75 hours. Then if you use your calculator, divide 152 kilometers divide by 1.75 hours would give you 86.6/7 kilometers per hour. That is question B. Last part, C. Calculate the average speed in kilometers per hour of the car for the whole journey. So we look at the graph. The whole journey from Kuala Lumpur to Ipoh is 205 kilometers, and the time is from 12 to 3:20. So again, the formula for speed would be distance divided by time. So again, distance is 205 kilometers divided by time. Time 12 noon to 3:20. That would give you 3 hours and 20 minutes. In this case, 20 minutes will be equivalent to 1/3 hours. Therefore, you can divide this by 1/3 hours. So then, using your calculator, you should be able to get the answer as 61.5 kilometers per hour. Question 10. Table 1 shows some members of Red Crescent Society and St. John Ambulance Society that are instructed to do an outdoor tasks at various places during the flag day. So the table shows boys, girls from Red Crescent Society and St. John Ambulance Society. Boys, Aiman, John, then we have Nancy, Mary, Fatin, Cindy. So the boys will be Aiman, John, Nancy, and girls Fatin, Cindy, Mary. 2 members from the societies were dropped off at random at those places. So let's look at the question now. A. List all the possible outcomes of the event in this sample space. You may also use the letters such as A for Aiman and so on. Okay, let's start. Let's label Aiman as A, Fatin F, Cindy C, John J, Nancy N, and M, Mary. So this means you can choose any 2 members from these 6 members. For example, Aiman and Fatin, Aiman and Cindy, and so on. Let's list down the members. So we will start with Aiman and Fatin, Aiman and Cindy, Ayman and John, Ayman, Nancy, and Ayman, Mary. Then we will start with Fatin, Cindy, Fatin, John, Fatin, Nancy, and Fatin, Mary. Then we have Cindy, John, Cindy, Nancy, Cindy, Mary. Then we have John, Nancy, John, Mary, and finally Nancy, Mary. So then these are all the possible 2 members from the society to be dropped off at random places. So there are total of 15 possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's continue part B now. Let's look at the question. Part B, by listing down all the possible outcomes of the event, find the probability that 1, a boy and a girl, meaning you must pick 1 boy and 1 girl. So in your choice, it cannot be 2 boys or 2 girls. It has to be a combination of a boy and a girl. And part 2, you have to find the probability of both members that were dropped off at a certain place are from the same society, meaning that if you choose from Red Crescent, it must be both members from Red Crescent or both members must be from St. John Society. Okay, let's look at the possible choice. For boy and a girl, let's look from the choices that we have. We have a choice of 15 combination here. So let's pick a boy and a girl. Ayman, Fatin, yes. Ayman, Cindy, yes. Ayman, John, no. Ayman, Nancy, no, because both are boys. Then we have Fatin, Cindy, both girls. Fatin, John, yes. Fatin, Nancy, yes. Then we have Fatin, Mary, no. Cindy, John, yes. Cindy, Nancy, yes. Cindy, Mary, no. John, Nancy, no. John, Mary. John, Mary, yes. Nancy, Mary, yes. So 1, 2, 3, 4, 5, 6, 7, 8. Let's double check again. Ayman, Fatin, Ayman, Cindy, Ayman, John. Okay, there's one more Ayman, Mary here, which I left out. Okay, so there's another one, Ayman, Mary. So Ayman, Fatin, Ayman, Cindy, Ayman, Mary. Fatin, John, Fatin, Nancy. Cindy, John, Cindy, Nancy. John, Mary. Okay. John, Mary, and Nancy, Mary. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a total of 9 possibilities of picking a boy and a girl to be dropped off at a certain place. Therefore, the probability would be 9 out of 15. That is question B, part 1. Let's look at part 2 now. Again, they say both members must be from the same society, meaning that let's look at Red Crescent Society. Red Crescent Society will be Ayman, Fatin, Ayman, Fatin, Ayman, Cindy. Ayman, Fatin, Ayman and Fatin, Ayman and Cindy. Then we have Fatin and Cindy. So 3 possibilities from the Red Crescent. Similarly, for St. John's, we will have John and Nancy, John and Mary, as well as Nancy and Mary. So there are 6 possible outcomes. Therefore, the probability that requires your answer would be 6 out of 15. So you will have 4 marks for part B, 2 marks for each probability. Question 11. Diagram 8 shows sectors OJKL and OMN with common center 0 respectively. You are required to calculate A, the perimeter in centimeter of the whole diagram, and B, the area in centimeter square of the shaded region. Let's look at the diagram again. This is the radius for this sector JKL, which is 10 centimeter, and for the radius of ON would be 10 centimeters plus 5 centimeters would be 15 centimeters for ON. So for question A, calculate the perimeter. So what is the perimeter? It would be OJ plus the arc of JKL plus LM plus the arc of MN plus NP plus PO, and this is the perimeter of the whole diagram. So let's write it down. For question A, perimeter would be OJ plus arc of JKL plus LM arc MN followed by NP plus PO. So we know OJ is 10 centimeters, and the formula for a sector would be 2 pi r times the sector angle. So the angle is, if we look at the angle, how do we calculate the angle for arc JKL? We have 50 degrees here, 80 degrees here, and we know a circle is 360 degrees. So this would give you 310. Okay. Let's calculate now. The angle would be, question 12 has got section A, B, C and D. Let's look at question A. Complete table 2 in the answer space on page 28 for the equation y equals to 30 over x by writing down the values of y when x is 2 and when x is equals to 5. That will give you 2 marks. And B, for this part of the question, use the graph paper provided on the page 29. You may use a flexible curve rule. Using a scale of 2 centimeters to 1 unit on x-axis and 2 centimeters to 5 units on the y-axis, draw the graph of y equals to 30x from the range of 0 to 7. And question part C, once you have drawn from the graph in 12b, find the value of y when x equals to 2.6, and part 2, the value of x when y equals to 17.5, followed by the last part, D, draw a suitable straight line on the graph in 12b to find the values of x which satisfy the equation 30 over x equals to negative 5x plus 30 for a range between x between 0 to 7, which is equivalent to 4 marks. So A, B, C, D carries 12 marks. Let's begin with section A first. So if you turn to page 29, it gives you the answer page, which shows a table which has given to you with some of all the values of x from 0.6 up to 7, and y values are given except for when x is 2 is missing and when x is 5 is missing. Therefore, you know the equation given to you equals y equals to 30 over x. So if your x is 2, then your y would be 30. You have to divide by 2. So 30 divided by 2 would give you the answer as 15. Same goes to when x equals to 5, then 30 divided by 5 would give you the value as y as 6. This means when x is 2, y is 15, and when x is 5, y would be 6. So that is question A. Moving on, let's look at question B, and here you have to use the graph paper given to you in page 29. Okay. Let's look at the question again. Question B. For this part of the question, use the graph paper and page 29, and using a scale of 2 centimeters to 1 unit in x-axis and 2 centimeters to 5 units in y-axis. So you have been given the graph paper. Using a ruler, you have to draw your x-axis and y-axis. Let's begin with the y-axis. This is your y-axis. So this would be your y-axis, and then your x-axis horizontally. This is your x-axis. So this you can label it as x-axis. Then they say for every 2 centimeters is 1. So this would be 1. We'll start with 0, 2, 3, 4, 5, 6, 7. Why do I stop at 7? Because the question says use a range of x between 0 to 7. Whereas for y, they say for every 2 centimeters is 5 units. So it's 5, 10, 15. So 15, 20, 25, 30, 35, 40, 45, 50. You can stop at 50 since the table shows that the largest or the biggest number is for y is 50. So once you have labeled, then we have to put in the points according to the coordinates. So the first point, when x is 0.6, y is 50. So when x is 0.6, y is 50. Then we have when x is 1, y is 30. When x is 2, y is 15. 1.5 is 20. And then when x is 3, y is 10. When x is 4, y is 7.5. And when x is 5, y is 6. Y is 6. And when x is 7, y is 4.3. So once you have put in all the coordinates, the points, then you can use your curve ruler and join all the points, and it will look like a curve as shown. Okay, let's join all the points. So we will join and you will get a curve in this shape. So that is question 12B. Moving on, let's look at question 12C. Question 12C says, from the graph in 12B, find part 1, the value of x. The value of x when y, the value of y when x is 2.6. 6, and part 2, the value of x when y is 17.5. This means that you have to refer to your graph in order to get the coordinates accordingly. So what is the value of y when x is 2.6? When x is 2.6, then we will look for the value of y accordingly. So let's estimate when x is 2.6, when x is 2.6, and to get what is the value of y. So this is your value of y. So this would be your answer. So if you will look at your graph, you will get a range between 11.5 or so within any values between 11 to 12 can be an acceptable answer. Part 2, when y is 17.5, when y is 17.5, what is x? So if I were to put 17.5 here, and what is your value of y, x here? So here you will get, if you use your graph, this would give you a value of 1.5. So any values between 1.4 to 1.8 can be accepted as the answer because you are estimating using your graph. Okay, that is part B. Part C. Now let's move on to the last part, which is part D, which requires you draw a suitable line on the graph paper again and find the values of x which satisfy the equation 30 over x equals to negative 5x plus 30 for the range between 0 to 7. So if you see from the question here, okay, we can see that y equals to 30 over x. So we can also say this is y. Y equals to negative 5x plus 30. So the easiest way to draw y equals to negative x plus 30 would be, let's say if x is 0, y would be 30. So one point that we can find would be when x is 0, y is 30. Next, when y is 0, what would x be? When y is 0, then we can actually simplify by substituting and say that when y is 0, 0 equals to negative 5x plus 30, therefore 5x equals to 30. This will give you x as 6. So going to the graph, so when y is 0, x is 6. So then you can draw a straight line connecting both the points 30 and 6. So you get a straight line. So the question says this is y equals to negative 5x plus 30 and this is 30 minus x. That means they are looking for this value and this value. So you can estimate this value. You will get about 1.3. It shows 1.3 and here can give you a value of 4.7. If you can get a range between 4.6, 4.8, it is still acceptable. So this is question 12D.
Hi students, in this video I will show how to solve paper 2 question 13. In part A we have this diagram 9.1. It shows point P on a Cartesian plane and we can see the point P is here and there's a shaded rectangle. Transformation T is a translation of 4 and negative 3, while transformation S is an enlargement about the center, negative 5
2 with a scale factor 2. State the coordinates of the image of point P under the following transformations. In part A, the transformation is t square, and in part 1 is t square, part 2 is ts. Now let's see where is the location of this point P. First of all, point P has a coordinate of -3 and 3. Alright, now let's solve the part 1. Now remember, t square means we carry out the transformation t 2 times. So it's not the square in algebra, it means really that we carry out the transformation 2 times, and t is just a translation. So we just have to take the coordinate of P, and because the translation is 4, means the 4 refers to the horizontal transformation in the x-axis, and the -3 refers to the vertical translation. So for -3 acting on this point P, so we need to move the point P 4 places or 4 units to the right. So 1, 2, 3, 4, and then -3 means go down 3 units. So 1, 2, 3, then we end up with here. But remember, this is t square, so we have to do the same thing one more time. So again, go to the right for 4 units. So 1, 2, 3, 4. Then go down by 3 units. 1, 2, 3. So in the end, we end up with this point, which has a coordinate of 5, 5, and -3. So now we can write the answer. Of course, on the next page, the answer for the coordinate of image of P under t square would be 5, -3. Alright, now the steps, earlier we were doing the graphical way. We can actually do it using matrix. So the point P has a coordinate of -3 and 3. So this is -3 and 3. Undergoing translation 2 times. The translation is 4, -3. So we end up with -3, 3 plus 8, -6, and this gives us 5, -3. Okay, so this would be the alternative solution. Okay. Now let's look at part 2 then. Part 2, we need to perform transformation of TS on point P. Now S is an enlargement about center -5, 2 with a scale factor of 2. So -5, 2 is located here. -5, 2. So it's here. So means we have to enlarge this thing with a scale factor of 2 about the center here. So then we can now join this line, for example, and then just double this. So then we will end up here. This will be the P prime. And we can do the same thing, although this will be the answer. But if you want to do this whole transformation for enlargement on the whole shaded area here, we would get this is 2 units. 3 means 6, so 2, 4, 6. Like this. The point is, so P prime, the image of P will be here. So that will be just the enlargement. Now we have gotten the location of point P under enlargement. Now we need to carry out translation. So as before, we just need to move along this point. So remember, it's 4, -3. So we will do 1, 2, 3, 4, and then go down by 3 units. 1, 2, 3. So this will be the final location of the image of point P under transformation T and S together. So the answer would be 3 and 1. Okay, so that was a solution for part A. Let's look at part B now. In part B, we have diagram 9.2. It shows geometrical shapes K, L, M, and P, which is this one. On the right hand side, K, S, R, Q, P, which is this one, and K, T, U, V, W. K, T, U, V, W, which is the big one, drawn on a Cartesian plane. Alright. Part 1, it says K, T, U, V, W is the image of K, L, M, and P under the combined transformation Y, Z. Describe in full the transformation for Z and Y. Now, the K, T, U, V, W is the big one, so this is the big one. And K, L, M, and P is the small one on the right. So we have to relate this, and it seems there are two transformations we have to do. So the question said this big one is the image of the small one under transformation of Y, Z. So then it seems like we can actually transform this small one. We can flip it or reflect it about this axis to get this, and then we just enlarge, which means Z could be just a reflection, and Y we enlarge it, enlargement. Okay, so then we can now write down the detailed answer on the next page for B part 1 part A. Z, we can say Z is a refraction about the y-axis. Okay, then the transformation Y would be enlargement. So we can say Y is enlargement about the center would be here, point K, which has a coordinate of 0, 1. So about 0, 1 with a scale factor of 2. Now we know it's 2 because you can see SK is 2 units, then TS once after we enlarge is 4 units. So in terms of the length is scale factor of 2. So there we go, we have the two transformation Z and Y described in detail for part B1. Now before I move on to part B2, notice that the question 1 here for transformation Z and Y, the answer actually we can actually swap because the steps or the order doesn't really matter. For example, we can do the enlargement first about the same point here, so we can actually make this like this. We can enlarge it with a scale factor of 2, and then we flip it over, we reflect it, which means we can swap this, it doesn't really matter. Okay, anyhow, let's move on to part B2. So B2 is given that KSRQP represent a region of area 30 meters squared. So KSRQP, which is this one. So it says this is 30 meters squared. So this area here, 30 meters squared. Calculate the area in meters square of the shaded region here. Now, since this KSRQP and KTUVW is related by enlargement with a scale factor of 2, so we can easily find the answer, whereby the area of the shaded region must be the big one, which is area of KTUVW minus the small one, which is area KSRQP, which is given. So this is the 30 meters square. Now what about this one? This one, we know the scale factor is 2, so we have to multiply 30 times 4. So we have 30 times 4 is 4 because we have to take the scale factor. The enlargement factor is 2 to the power of 2, so it's 4. Then we have here 120 minus 30, and then in the end we get the answer of 90 meters squared.
Question 14. Diagram 10 shows the marks obtained by a group of 36 students in a mathematics test. So these are the 36 results obtained by 36 students for their mathematics test. You are required to, question A, based on the data in diagram 10, complete table 3 in the answer space on page 36. That gives you 4 marks. Part B, based on table 3, calculate the estimated mean mark of a student. Part C, for this part of the question, use a graph paper provided on page 37. By using the scale of 2 centimeters to 5 marks on the horizontal axis, which is your x-axis, and 2 centimeters to 1 student on the vertical axis, y-axis, draw a frequency polygon for the data. And finally, part D says, based on the frequency polygon in 14C, state the number of students obtained more than 40 marks, that is 1 mark. Okay, let's start with question 14A. Complete the table in page 36. So this is your table given in page 36, and you are required to complete the frequency table in page 36. So they have given you the first class as 21 to 25 and the last class from 56 to 64. So based on the information given, your first class, your lower limit starts with 21 and your upper limit is 25. Therefore, the class width 21 to 25 is 5. So based on that, you can continue the other classes that are empty. So 21 plus 5 would be 26 to 30, then 31 to 35, 36 to 40, 41 to 45, 46 to 50, 51 to 55, and lastly 56 to 60. Now how do you find the frequency? Go back to the table here and you have to manually look at the number here. So meaning that look for the first class 21 to 25, all the numbers that are below 25, 21 to 25. So we will go column by column. So we will look for 21 to 25. So you have to look at one by one, and you can see that's why it is stated 0. Next, 26 to 30. 26 to 30, if you look 26 to 30, 26 to 30, so you can see 29 here, and you have to look row by row, column, and look for any numbers that is below 30. 26 to 30. So we have 27 here. So you can see that 26 to 30 would be frequency 2. So you have to do the same for all the classes. Next, 31 to 35. 31 to 35. 31 to 35. So we have 1, 2, 3, 4, 5. So we have 5. Then 36 to 40. 36 to 40 we have 1, 2, 3, 4, 5, 6, 36 to 47. And then 41 to 45, that is the most that you have, and you can see there is 41 to 45, you will have 10, and then 46 to 50 you have 8, and then 51 to 55 you have 4. You must make sure that when you add up the frequency, the total frequency must give you 36. So you can count and see that you must get 36. Next column, midpoint. Midpoint meaning that 21 to 25. Why is the midpoint 23? Now, to find midpoint, you have to add lower limit plus upper limit divided by 2. So therefore 21 plus 25 divided by 2 will give you 21 plus 25 divided by 2 will give you 23. So this follows the same. 26 plus 30 divided by 2 will give you 28. This would give you 33. This will give you 38, 43, 48, and 53, and finally 58. So you have completed question 14A. Next, moving on to question 14B. Based on table 3, calculate the estimated mean mark for a student. Now, for formula for mean, for part B, the formula for mean would be mean is the total fx divided by summation of f. So we know the summation of f is 36. Total number of students is 36. Now how do we get fx? So this is f and we will use the midpoint as x. So you are supposed to multiply each row f times x. So the first row will give you 0. Next is 2 times 28 plus 5 times 33 plus 7 times 38 plus 10 times 43. So you have to do for all the numbers, plus 8 times 48 plus 4 times 53, and the last row is 0. So when you times all, you should get a total of 1513 divided by 36. So your final mean would be 42.03. So that is the estimated mean for question 14B. Let's continue with question 14C. Question 14C, you are required to draw a frequency polygon on the graph paper given to you on page 37. So let's go to page 37. you are supposed to use 2 centimeters for 5 marks in x-axis and 2 centimeters for 1 student in y-axis. So this is the graph paper that is given to you. Again, you have to draw your x-axis and your y-axis accordingly. This is your y-axis, vertical y, and this is your x-axis. Label it as x-axis. Once you have labeled y-axis and x-axis accordingly, now if you look back at question C, it says use 2 centimeter to 5 marks on the horizontal x and 2 centimeter scale to 5 marks, and then 2 centimeters to 1 student in y-axis, meaning that every 2 centimeters in your x-axis will represent 5 marks. Now, at what point can you start for the x-axis? Looking at the table that you have prepared earlier, the lower limit starts from 21. So it will be good if you can start your x-axis by labeling the first point as 20 marks, followed by 25, 30, 35, 40, 45, 50, 55, and finally 60. As for the y-axis, every 2 cm will represent 1 student, because looking at the frequency table here, the highest number is 10. So we can start labeling it as student 1 for every 2 centimeter as 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your x-axis will start from 20 to 60 and your y-axis would start from 1 to 10. So now go back to your table. Which point are you going to take for the x-axis? It would be the midpoint. So we look for the point 23, 0, 28, 2. So you have to plot 23, 0, 28, 2, 33, 5, 38, 7, 43, 10, 48, 8, 53, 4 and 58 as 0 accordingly. So if you look here, you have started the axis from 20, 25. So you go to 23 and then that is 0. So that is your first point. When it's 28, then it is 2. So this is 2. So you have to plot until you reach point 58 as 0. So once you have all your points, take a ruler and join all. Using a ruler, you join all the points accordingly, and then that is your frequency polygon, and you'll get a diagram something looking like this. Okay, so make sure you use your ruler and join all the points that you have found accordingly. All the midpoint according to your frequency table that you have found in question 14a. So the table has got all the frequency and you join all the points. So this is your frequency polygon. So that is question 12c. And last question for 14 is question 14d. Based on the frequency polygon in 14c, state the number of students who obtain more than 40 marks. Go back to your graph and go to your x-axis, go to 40. So this is 40. So they want to know how many students actually got more than 40 marks. All those students who got more than 40 marks, that would be these, and this is 0. So if you can see, more than 40, the first point shows 10. Okay, the first point shows 10 followed by 8, 4. So this is 10, this is 8, this is 4, and this is 0. Therefore, the answer for question D, part D, number of students who got more than 40 marks would be 10 plus 8 plus 4 plus 0. That would give you 22 students. So that is the last question for question 14. 22 students.
Hi students, today in this video I'm going to show how to solve question 15 of paper 2. Now note that you are not allowed to use graph paper to answer this question. In part A, we have diagram 11.1. It shows a solid prism with a rectangular base JKLM on a horizontal plane. So JKLM is this horizontal. The surface MQRSTL is a uniform cross-section of the prism. So where is the MQRSTL? This is a uniform cross-section. Means it's vertical. Triangle STU and PQR are horizontal planes. So STU, this is horizontal, and PQR, these are horizontal. Okay. Edges PJ, RS, and UK are vertical. So we have PJ, RS, and UK. So we can actually label it. So this is vertical, this is horizontal, UK is vertical, so we can put a right angle here, and this RS also is vertical. Okay. Finally, PQ and TU, they are equal and is 3 cm long. So PQ here 3 cm, TU also 3 cm, so we can label here, it's not labeled, 3 cm. Okay, like this. Now let's look at the question. Draw to full scale the elevation of the solid on a vertical plane parallel to KL as viewed from direction X. So means from the right. We view these things on the right, what we should see. Now to help us visualize this, I actually have make a small model to scale actually, so we can have a look. If we build a model corresponding to this solid prism, it looks something like this. Okay, so we have JK, so JKP, and we have the PQR is the top bit here, PQR, and S is here, U bit here, T is here. Okay, so if we view these things from the right, we're going to see this. Can you guys see? So it looks something like this. So basically we're going to see just a rectangle. Okay, the curved bit here, this is the weird part. The curved bit here is will not be very clear if we view it from position X. Okay, anyhow, let's get to the drawing. So basically we're going to see this vertical line. So we need 8 cm height, 3 cm width. So let's see. So let's start from drawing a horizontal line 3 cm. So let's do here to here. Remember the question asks for full scale, so we have to do just 1 cm for 1 cm. So this is 3 cm. 3 cm. And then we need 8 cm height. So let's go ahead and do the 8 cm. 3 cm. Look at this. Alright. Then we are going to see this line here, which is at the middle, so 4 cm. Okay, now basically the drawing is done. We just have to label the corners. So we're going to see here K first, then J is behind. So because we look at this side, so we're going to see K and then J is behind. So we will do, remember the notation will be, we write the symbol for the corner that we see, and then the hidden one we do a slash and then the letter. Next here, this bit is going to be L and M, so there will be L, M, S, T, U. U is the one, nothing behind, so S, T, S first, then T, R, Q. So R, Q, and P is just 1. Okay, so then we can just finish off by labeling the distances, or rather the length. So it's 3 cm, then it's 4 cm here. 4 cm. So that would be the complete diagram. Okay, now let's look at part B. Okay, part B, we have another solid cuboid with a rectangle base, JMDE, and is combined with the prism in part A at the vertical plane JMQP. So JMQP, so the prism earlier is joined with this cuboid. The composite solid is shown in figure 11, diagram 11.2. The base EJKLMD lies on the horizontal plane. So it means this is horizontal. Okay, draw to full scale. Part 1, the elevation of the composite solid on a vertical plane parallel to EJK as view from Y. So view from here. So when view from here, of course, we're going to see this face, which is EFPJ, and then this face, which is JKU SRP. Okay, so now the cuboid gives us basically the elevation. It's just a rectangle, flat vertical rectangle. Here, this bit is flat. This bit is vertical. This bit is actually curved, as we can see using the model that I built. So here we have the cuboid, which is this one, and the prism here. So if you join them together like this, we can see. So we're going to see this face, which is the FPJE as a just a perfect directly rectangle. Now this bit here, see, this is curved, right? But if you view from Y, like in front, from the front, we're going to see this inverted L, or this like a flag thing, flag shaped thing. Okay, so let's go ahead and draw the diagram. Now we are going to have two parts, right? So one is the rectangle, one is this bit. So let's see, let's draw, let me try to draw this line first. So let's do, we need 8 cm, so 8 cm, so it's more than enough space here. So let me just draw a reference horizontal line. We can use these lines and then use the plastic ruler to get us a nice vertical line. Okay, then what we need, this bit is actually 4 cm only, because 4, right, remember? 4 cm here. This bit was, let's see, it was 2 cm. This bit, so 2 cm here, JK. I think that's all we need, alright? So it means we need just 4 cm here. So let's get the 4 cm. Let's start from this point. The height we need 8 cm, so it's more than enough space. Now let's do a 4 cm here. Okay, so 4 cm. So we have the 4 cm here. Now we need this line 8 cm at right angle to this vertical. So let's go ahead. get a nice horizontal line first, and then we measured 8 cm. Okay, it's not long enough. Let's extend it a little bit. Okay, so we have the 8 cm here. So 8 cm, 4 cm. So this, let's put the 4 cm mark also. Here will be the 4 cm. This is Q, by the way. This is R. We can already start labeling the corners. All right. Now we need one vertical line here and horizontal line. This is TS is 2 cm, 2 cm, 2 cm, we get to 4 cm. So we need this line. So this would be 2 cm. Let's mark 2 cm. Here, okay, so 2 cm. Then let's do this one now. This one we need 8 cm vertical line. So something like this. So 8 cm. Then we're going to need a horizontal line here. And not 8 cm because we are missing this bit here, so it's only 4 plus 2, 6 cm. So 6 cm here at the base, 6 cm, and we need a 4 cm, so 2, 4. Then we can join. This is the J, by the way, right? So join with this bit here. So we get so we got the nice rectangle here. Make it darker a bit. So okay, so almost there. So now this is the 2 cm, which is, so we can now label this is E, D, this is J, M, so E, D, J, M, KL, by the way. So KL, we haven't, let's join this line, final line, I think. So this is K slash L. This one, U slash T, U slash T, and this is S. Then let's erase the redundant line. Okay, then this one is FG, so FG, F slash G. Now, oh, this is P slash Q actually, P slash Q, so P slash Q. And then we just need to put in the dimension, so this is 2 cm, so 2 cm, this is 2 cm, this is 4 cm, 4 cm, this is 8 cm. So I think we got everything. So let's to check it. Earlier we saw in this model, we're going to draw, we can see this and this. So you can see exactly like what we draw. Okay, so that is the solution for B1. Let's move on to B part 2. So B part 2, we just need to draw a plan to full scale the plan of this composite solid. It means plan means you look from above the area view. Alright. Okay, the area view we're going to see this bit from the top. We're going to see GQPF 4 by 3 rectangle and probably a triangle, but then the thing is this line SU is not really parallel or at the same angle as PR. So again, let's look at the model. So we'll see this bit here, if we view from the top, right? So we see this bit here, and then this one, if you look carefully, students, what do you see? We see this triangle, which is PQR, but there's this bit here. This smaller triangle, we can actually see a bit of this, because this thing is curved, see? That's the tricky part. So basically we're going to see this triangle and this bit, which is kind of another triangle. So let me draw out and show you. Okay, right. So the easiest one, of course, the left hand part. Okay, so left hand part, which is the rectangle. So again, we can use this line. We need 3 by 4. So let's draw a nice vertical line, 3 cm. Start from here. 1, 2, 3. Mark it. Okay, so 3 cm by 4 cm. So we need 4 cm. Horizontal 4 cm, actually 8 cm. So let's go ahead and draw 8 cm horizontal. Now let's measure it. So 8 cm somewhere here, 4, 0. So we have 4 and 4. Now we can, okay, let's do another line here. Try to get it as accurate as possible. I'm using this side as the reference. Okay, now we don't need 8 cm because there's again missing bit, right? But we need at least the 4 cm, so let's measure it. 4 cm is here. So let's close this because we're going to see this line, right? From the top. So this is the PQ, line PQ. Okay, so then we have, let's label 3 cm, 4 cm. Okay, then PR, we can see this is R, basically R slash H, by the way. R slash is vertical. So let's join P, this is actually PJ. Because we see from top, we see P, and then J is hidden behind. So then just join this. Join P and R. Okay, so this will be the top one we see here. Then, but there's this bit. So remember, we can see this 2 cm line. See, right? This 2 cm line. If you view from the top, we will see. We can actually see this line. See, this line. So this is the 2 cm. So 2 cm. Let's measure 2 cm up to here. Make a small dot, then we just join, and that's it. We are basically done. So all we need to do now to finish up is just, of course, erase the extra lines and put in the corners and the distances. And then just thicken the line a little bit. Okay. Now we have, okay, this one is what? G, look from the top, right? G, GD. So G slash D, F, E, F slash E, PJ already done, Q, M, RS done. Okay, this one, okay, this is, be careful, this one is here, right? And it's U and K. This is vertical line, remember? Vertical line. UK, so UK, and what else? Actually, there's one more, because there is one hidden line here. Not this one you can see. This line, if you view from the top, this line, TU. TU cannot be seen. See, look at the model. This is TU or UT, right? If you view from the top, this line is obscured, but any lines which are obscured or hidden, we have to do dash line. So then we should do a vertical dash line here to account for this bit here. So this is TU, right? So let's measure the 2 cm mark here. 2 cm mark. Then we just draw this. Give it a nice dash line, and then again label. This is hidden, so just label TL. Sorry, TL hidden. Right, so TL is here. So T, comma L, and then 4 cm. This is 2 cm. This is 2 cm. This is also 2 cm. Okay, so that would be the full answer for part B. Thank you. This is B2, by the way. Question 16. Diagram 12 in the answer space shows the location of points J, L, and M which lie on the surface of the Earth. O is the center of the Earth. The longitude of M is 30 degrees west. K is another point on the surface of the Earth such that Kj is the diameter of the common parallel of latitude 45 degrees S. So you can see O, L, M, and J with the longitude and latitude. Now, question A1. Mark and label point K on diagram 12 in the answer space. So we have to go back and look at, they say K is another point on the surface of the Earth such that Kj is the diameter of the common parallel of latitude 45 degrees S, and that means we know J is here, so Kj is a diameter, so means K has to be this point, so that is the line Kj is the diameter of the common parallel of the latitude 45 degrees south. So then we can mark this point here and just put K. So that would be what we have to do for A1. Now let's look at A2. Hence state the longitude of point K. Now longitude, okay, so it's about, is it east, west, how many degree? K is kind of opposite to J. We know the longitude for J is 50 degrees east. So it's easier if we draw a small diagram to indicate which is viewed from the north, and then we can label J, and we can see K and J in the opposite side of the circle. So let's go ahead and do it. So let's do it here, a small circle. Okay, this is view from north, means we view from the top. So we're going to see this one, this circle represent this. So J, let's do a horizontal line. This is the diameter, this is O. Above, okay, this is J, this is K. Now where is the Greenwich meridian? It's going to be, because this thing is for 50, J is at 50 degrees east, so this is east, this is west, general direction. So 50 degree may be something like this. From this 50 degree means this is actually, this line here is the Greenwich meridian. Right, so from here 0 degree goes east 50 degrees, so this is 50 degree. Then the longitude for K must be from here go to west, so this would be 180 minus 50, which is 130 degree west. So that would be the answer for longitude of point K. So we now know it's 130 degree west. Okay, so that is the answer for part A. Let's move on to B. B, it says L, another point L lies due north of M. So that's L here. And the shortest distance from M to L measured along the surface of the Earth is 7,500 nautical miles. Calculate the latitude of L. So it means this one. Okay, latitude means is it north, how many degree, and south. This is obviously north. So then basically they said from M go to L along the surface, the shortest distance is 7,500 nautical miles, means is this one. If we just draw this, okay, so we need to translate this 7,500 nautical miles into this angle. Once we find this angle, we can work it out, right? So remember that the meaning of 1 nautical mile. 1 nautical mile is equal to 1 over 16 degree of latitude. Okay, so then we have 7,500 nautical miles. We can change it to a degree in latitude, so that will be this angle LOM. So angle LOM is 7,500 minute, or this is basically minute, okay, which is 7,500 times 1 over 60 of 1 degree, and this gives us 125 degree. So we know this is actually 125 degree. Now M, the what's this? Yeah, longitude of M is 30 degree. Sorry, not this one. South. Hang on. Sorry, 30 degree west. But we need the latitude. Hang on. Oh yeah. M is on the same parallel, right? So it's 45 degrees south. This is key. So this M has the same latitude as J, so 45 degrees. That's right. 45 degrees south. Then you go up. So that means latitude of L must be 45 degrees south minus, because you go up, so minus 125 degrees. This gives us, if you take 45 minus 125 is negative 80, but negative 80 means it's above, so it's 8, or in the north direction, so it's 80 degree north. That is the answer. Okay, so that is part B done. Now let's try to solve part C. Part C, to calculate the distance in nautical mile from KDU east to M measured along the parallel, common parallel of latitude. So that is K goes to M. This is the common parallel of latitude. So K to M. Now to solve this, we will need a formula, and we will need the longitude. So M it has a longitude of it's given, I think, yeah, here, M 30 degree west, so let's write it down. M is 30 degree west. K, we have solved it, is 130. This one is 130 degree west. So this one 130 degree to the west, and this one 30 degree to the west. So now record the formula to calculate this distance. We will need the difference in longitude, means 130 minus 30 degree, multiply to convert it to nautical mile, we multiply 60, because 1 degree means 60 nautical miles, but because it's not along equator, so we need to multiply a cosine of the latitude. Now the latitude is 45 degree south, so cos 45 degree. Okay, then we solve it. We don't really need this sign. We solve this, we will get 4,242.64 nautical miles, and that is the answer. Okay, now let's move on to the final part of the question, part D. An aeroplane took off from K and flew due east to M along the common parallel of latitude. So from K, it goes due east along M, so it's the same distance earlier. The average speed of the aeroplane for the flight was 750 knots. Okay, so the speed is given. Calculate the total time in hour taken for the whole flight. Now this is easy if you recall the meaning of knots. The speed in knots means how many nautical miles in 1 hour. So then we can just simply write the general formula. Speed, of course, is distance per unit time. Okay, so here we are given the speed 750 knots, which equals to this distance in the km distance divided by the time in hours. So 4242.64 nautical miles divided by t. So the time will be, you solve this, we are going to get 5.66 hours. So that is the answer. Thank you.